Good morning, everyone. Are you able to hear me okay? I appreciate everybody joining here this morning. Right, or up. I was the originator of the Nikola Tesla collaboration group that started about 5 or 6 years ago. And the main concept behind what that's all about is giving back to the world concepts, ideas, multiple things that have helped each other. The group has in it right now over 3,000 people, and they're from all over the world, all different types of industries. My belief is that, just through social media alone, the amount of knowledge and information that's available out there today is phenomenal, but it's getting it defined down to somebody that's actually done it, played with it, worked on the equipment, been involved in different things over the years. And so I've been very blessed in my life. I'm 65 now, but I've been in the electric motor industry my entire life. If you'd like to join this group, I sent a link to everyone so that they can actually join it. Just click in and join, and then I'll let you into it. But we literally have today access to about $10 billion worth, or $10 billion, 10 billion years of experience. And a lot of things are becoming more and more complex every day. And so by sharing concepts and ideas with other people that have already done it, or, had experiences with it, it makes it a much easier process. And then know someone, to go to if you do have, a need for information. I've been a really big study of Nikola Tesla my entire life. I actually own one of his 1904 books that was all on alternating currents. It was given to me by one of my mentor teachers back, in the 70s, that he used to be with the IEEE. And my father had been, brought me into motor repair really young, but then the understanding of machines and power transmission, all this came a lot from Curtis Reed and a guy named Riedel Curtis, that both helped me tremendously in my life, that helped me understand synchronization, motors, all different types of motors. And so I'm at a point now where, I really want to give back as much as I can. I really feel one of my mentors was Zig Ziglar. You can have everything in life you ever want if you just help enough other people get what they want and need. And it's literally true. I've been blessed very heavily in multiple ways, and here to help in every way I can. Some background on myself: I've also worked heavily involved with EPRI in the 90s, doing application evaluations, very heavily involved in a huge project for plastic molding machines in the 95, where we installed a bunch of them on Ford Motor Plant, on one of their, or back then the old Aerostar car, and proved the technology of saving energy, properly on machines. This is my father shown here. He started in 1953, actually putting up wind chargers. Then he went on to build, there's still 7 motor companies, under our family name. They're in the Midwest, run by nephews, cousins. I got a son and a daughter, both in the industry. I've worked 40 years with multiple power companies around the world, a lot of them with PG&E, where I'm living here currently, and then also a lot with National Grid, Eversource, used to be Mass Electric, doing pilot studies on drive applications. I also highly recommend, if you want to get more and more information, is to really look into people that carry the ESA symbol. I have many mentors around the world, and also many friends of mine in the industry over the years that have really written a lot of the fundamentals. A lot of them are originally, ma and pa shops. Some of them now have kind of, evolved. Some of them went public in different ways, but they really wrote a lot of the fundamentals. When I was with my father back in the 70s, he used to be a chapter president and also was on the board of directors of this group. And they have this little Bible, what I call kind of like a little Bible from the electrical engineering pocket handbook that has everything you want to know about electric motors, controls, generators, wiring schematics. I use it still on a daily basis. I'll play this a little bit here.
When you think of electricity, you think of Edison. But there is one electrical genius who is nearly forgotten. A man who dreamed of giving the world an unlimited supply of energy. His name was Nikola Tesla. This is the story of a modern Prometheus who changed the world with electricity. It was Nikola Tesla who captured the power of Niagara Falls with his alternating current system and made it possible to transmit electricity to all of America and the world. Suddenly knew he could recreate this rotating field by powering the coils of a motor in different steps or phases, like the pistons of an engine. The resulting forces of magnetic attraction and repulsion would literally twist the rotor in a circle, the electrical equivalent of the wheel. And all this was accomplished with alternating currents. It would soon turn the wheels of industry around the world. Tesla was ready to unveil his motor to the world.
The subject which I now have the pleasure of bringing to your notice is a novel motor which I am confident will at once establish the superior adaptability.
So what I'm really talking about today is variable frequency drives that are controlling electric motors, and then in turn, actually, which a lot of people have seen them, heard them, they've been around for a long time, actually in the 70s and 60, or back in the 60s, the guy named Nolan actually wrote the first patent on, first it was soft starts, then he wrote it on from variable frequency drives. Then a lot of my knowledge came over the years. I was very blessed working with a lot of the Toshiba people down in Houston. Some of them are still my personal friends. I know, from all over the world. They've all expanded out from the 80s to different, multiple different companies. And so what we're really talking about is just controlling the frequencies and the voltage amplitudes to the motors, properly, and doing it cleanly. And so, as we're, whether it's a generator or a motor, there's a rotating field internally that is turning, and then it's, generating the power, and this is the output, three-phase power going out, or it can be in reverse, where you can have a, either aluminum barred rotor or a wound rotor here that you can feed it backwards, and it's the same concept, either a generator or, or a motor. This is what I want to talk about today, which was a project I did about 10 years ago, very heavily involved with, this shows here the picture, not really great, but shows the container load of drive controls that we put on this building. And this was the outcome of what we had in the building.
Hi, my name is Scott Manning. I've been with GDF Suez Pine Tree Power Fitchburg for about just over 2 years. I am the maintenance manager here at the facility. Pine Tree Power Fitchburg is a 18.5 megawatt wood-fired power plant. The plant generates enough power to power about 16,000 homes in an average community. At the facility, we have about 45 to 50 electric motors that we were looking at reducing our in-house power consumption that would allow us to sell more power to the grid. And that's where Roger and him to the picture. So Roger came out to the facility and gave a proposal to look at all the electric motors and put in a application to National Grid to cover a portion of the expenses. At the beginning of the project, I was very skeptical in the fact that why would the grid pay for the amount of material that they were looking at. So after talking further, the project seemed very feasible, and it could reduce our power consumption by about half a megawatt. Roger's group and the people he had come out evaluating the plant were extremely professional, very polite, and very engaged in the project. There was never a point during the project where you felt left out or in the dark on anything. Everything was up front, everything was in black and white, and you know, they processed things in a fair amount of time. They were very open to communicate with you. You never felt like there wasn't any information that you didn't have.
So what we ended up doing there is actually implementing about 44 electric motor retrofits, putting drive controls on their boiler feed motors, the draft fans, the cooling tower systems in the buildings. And we were able to get close to, I think the utility company put in over $700,000 worth of energy money, which came from a lot of the money that's out there, which even today, you know, for clean energy is available. And I've been blessed with a lot of friends and access to understand how to get that money and what places to go to look for it and get it to help not only the power company or the power plants to do it, but also the end users, because we're all, you know, looking for ways to generate more power. After that, originally it was about a 16 megawatt plant. And when it got done, as you heard, it was about an 18.5 megawatt plant. What happened is that they were also able to, once they got control of those boiler feeds properly, get some more flow and pressure out of them by overspeeding them, enhance the performance balance, you know, going into the boilers, and also the draft fan tuning. And then we also helped him get incentives to put Van de Graaff drives on all of his conveyor systems, which were able to speed it up. So we were able to get more, you know, total power out of it. So he got about about $400,000 worth of true savings just with the drives. But the real numbers came from when they were able to balance everything, because that's really what I think Tesla's always been trying to tell us to do, is to get, you know, every system into balance. And I think that's where, you know, I don't try to be in any way a straight VFD salesman. I try to be an application salesman, because having done pilot studies for the utility companies for several years on everything from, you know, small commercial, you know, pumps to, you know, very large medium voltage equipment, you know, I've been able to actually put my fingers on it, touch it, you know, and make it happen. And so, you know, a lot of people are not aware of, there's a lot of, you know, push towards solar, wind. But if we can cut that global utilization first, before we step into the factors of actually reducing, of adding more and more, you know, power in, and where electric motors are consuming 70% of the world's power, and approximately 52% of it's going into motion. And then HVAC, fans and pumps are about 19%, you know, lighting 16%, and 14% is going into IT and other electronics. But these areas here are like our large compressors, the, you know, the big heavy user stuff that a lot of people don't want to touch because they're worried about reliability. You know, it's working now, it's been working, it was installed because of the cost of VFDs that have, you know, dropped dramatically over the years. there's still a lot of applications in America where if you go, into Europe, and we have a facility in England that we do a lot of facilities now. And Barnaby, my partner there, has been doing this for, well over 20, 25 years. We do a lot of specialty work. We do a lot of specialty work, in other places in Europe on plastic processing. And so what I highly recommend is first, we need to do some real evaluations. And, I could help you get this metering or however you want to do it, but this tool has been a godsend to me.
Introducing the Fluke 438 Power Quality and Motor Analyzer. The Fluke 438 is a multi-purpose test tool designed to improve troubleshooting on electric motors and minimize downtime. Whether you're in a process plant or discrete manufacturing, electric motors are critical to your operation's success. The Fluke 438 lets you quickly gauge electrical performance, power quality, and mechanical performance of industrial motors. Using three-phase electrical measurements on the input and motor rating plate data, the 438 calculates torque, the most critical mechanical performance variable, speed, load on the motor shaft, and overall efficiency, without the need to install mechanical sensors. All this with a single tool, and all while the motor is running so you don't sacrifice uptime. Power quality issues, such as unbalance and harmonics, can cause motors to run hot, eventually stressing windings and accelerating failures. Motor failures lead to costly downtime, and the cost of waste associated with inefficient motors adds up. When testing direct online motors with the new Fluke 438, you get both power quality information and mechanical performance data in the same test with a single tool. With an intuitive user interface, optimized current probes, and at-a-glance motor status screens, the Fluke 438 gives you the motor troubleshooting information you
Sorry about that.
need to make better maintenance decisions and keep your plant up and running. Contact your local Fluke representative to learn more.
So what we have found is that by doing proper evaluations, getting the real data, where the motors are loaded properly, we found a lot of wasted energy. I've also got many partners in the fan and pump industries that share data and information that will help us do a very good evaluation of what's truly going on. A lot of factories today, they're looking at ways of saving, which I understand that, but their big focus is keeping those machines running, and even doing these evaluations about noise, harmonics, which do happen from variable frequency drives because we're not a fixed sine wave coming out of the power source to them. We've got a lot of applications that are outside of that, and now with solar and wind, a lot of power quality concerns out there, and then voltage balances and information. So we really recommend getting the proper testing evaluations done on facilities. But there's an amazing amount of dampers and throttles and valves that are still utilized in a circuit that you kind of just overlook or don't see. They were put in as design, and you need to look at those pressure drops and losses across them, or where it is, because if you can do that with motor speed, you're immediately saving energy. So this is an example of like a 50 horsepower motor with and without a VFD. There's multiple applications are out there that are the variable torque loads type applications, where they're the centrifugal fans and blowers, axial fans. Fortunately, My father used to have a manufacturing company that built big centrifugal fans and blowers and axial fans. And so it gave me an insight, really quickly, as I look at things, I can see areas where, where to do it. A lot of people overlook some of the constant torque load opportunities, but if you do, look at the mixing, if you have mixing or conveyors or compressors and those things, you can actually slow these down. It's a more of a linear horsepower drop, but there are energy savings compared to running it at fixed speeds. Again, a little bit more information about constant torque loads, variable torque loads. Your dampers, controlled with a VFD here shows the curve rating of horsepower and input power required, compared to outlet dampeners, variable inlet vanes, or if it's just a straight 100% flow, going out of the particular fan. And we try to take a lot deeper dive. Before it was expensive to even buy small drives, but micro drives, a lot of them that are out in the marketplace now are very, very reliable, and they're the size of almost a magnetic starter. So we have over the years literally done a lot of change outs of taking the motor starters out, and it does add up. And typically in the past, people were looking at, well, yeah, my avoided cost is maybe 2.5%, 2.5 cents a kilowatt. So is the payback going to be there? But today, with all of the peaking needs in the industry, you need to look at the amount of power that you're able to produce on out, because that gives you more and more production capability in a generation plant. This happened to be the big draft fans. We also look at the nameplates properly and the information, so that a VFD is properly applied to it to make sure it meets the proper voltage, winding capabilities, cooling properly in the motors, depending on the type of load it is. These were the 750 horsepower boiler feed pumps that were brought into the system. It also made a very unique thing that came from it, is once we balanced all these motors and all the flow properly in the building, the noise level of the building also dropped, because excess energy goes into heat and noise. And so a lot of it started going away. We've done processing plants where we've installed hundreds of drives on injection molding machines. Before they couldn't stand the ear noise was so high, they had to wear earplugs. After we were done, it calmed all the hydraulics and the noise down so much you could actually speak to each other in the building, because we were transferring the power from one load to the next properly. So again, with the background that I've been in, I really look deeply into the motors itself. My dad started me rewinding motors when I was 10 years old, and from that, over the years, I'm very alert to what can happen, what can't happen. This happened to be a case study where we were also able to get about $179,000 incentive for the customer, had about a million kilowatt hour savings, and about $138,000 of annual savings. That was at a 12 cent a kilowatt hour load. I also highly recommend that all the systems that are involved or people get involved with, that they can properly communicate with their BMS systems in the buildings. And we were able to integrate back to the BMS systems in many facilities across the country now, and understand the older, more analog and, Modbus based ones, or go all the way, deeper to a lot of the, backnet device nets, that are out there today that each have their own protocol. And, so we searched the proper, groups. I work on a lot of different, brand applications. We have partners all over the world that we, both buy and, get access to drive controls from, from the very big names to, people that aren't such big names, but maybe they were producing it for the other. There's a lot of, private labeling going on in the drive industry. Um, uh, Again, back to the custom applications, there's a lot of, custom opportunities out there that a lot of people just say, oh, well, that's constant torque. We're not really save energy. And we really have to we help them deep dive in to find that. These are also a bunch of accesses here in the United States that are available where you can, go to the Department of Energy and look it up, various applications. This happened to be, several of them that were in this facilities net group, motor decisions, motor matters, NEMA guides, and then the Consortium of Energy that has also done, a lot of research. Again, my point is collaborate, bring the people together, get the knowledge brought forward, look at existing applications, but do it fairly quickly. You can do a lot of evaluation by, looking at a base bit of information. These are still incentives that are available and under the, a lot of the mass saves programs that are out there, specifically, on prescriptive where it's called like a Tylenol for the headache, of how much money is available out there. And, we can assist you how to get the paperwork correctly, because where this money comes back from is the public utility commissions. And so, they want to verify that that deferred amount of energy or that deferred amount of additional production without, new infrastructure is how they're, accomplishing these costs through the utility rates. So there's a lot of money out there for it, but if the paperwork's not right, you're not going to get too far with it, or it'll go set in an engineer's file for a tremendous amount of time. And then they'll come back and ask questions. And because it's kind of a more of a niche market and they're so involved with so many other, industrial applications, and even down to just, changing chiller systems out, or, pumps, or, like they gave incentives for, the Van de Graaff, conveyor motors and stuff. It was the detail of the custom application that actually, helped get the incentive money for it. And now, drives even, over the last 10 years have taken another, big, drop in cost because of production costs. And so, we're involved with a lot of different ones, different brands. If you look at some of our YouTube channels, you'll see some of the, branding. We do a lot of manufacturing, and we